Hey everyone, welcome to DevConf 2020 online. So thank you very much for joining us and thank you for joining this talk. It's not an ideal situation, but we're all doing the absolute best that we can. I'm Mike, and for those of you that may not know me, I'm a Google developer expert in web technologies. I'm not sure why they like keeping me around, but I have a suspicion that it's because of my propensity to apologize for things, particularly JavaScript's weirdnesses. I am also a maintainer of contributor and maintainer of the Web Almanac, which is HTTP Archive's annual State of the Web report, which has some super cool people writing some really interesting insights on where the web was in the last 12 months and where it's probably going. I'm not a super cool person. I'm just the person that does the wiring and puts things together. I'm also a co-organizer of Josie.js, which is our local JavaScript meetup group in Johannesburg. It's super cool. We usually meet in this space, as you can see, on the third Thursday of every month. But for the foreseeable future, we're going to be trying to do something online. So wish us luck. Hopefully we can get it right as well. So what am I here to talk to you about today? Well, I'm here to talk to you about performance. Yes, performance is a really important feature, but one that we often neglect until it's way too late. And that's for a whole bunch of different reasons, but I think that's also for a separate talk. Let's focus instead on, firstly, reasons why we should care about this stuff. And maybe there's a whole bunch of stuff. Maybe you are interested in caring about your site performance because of a competitive advantage. Leading research indicates that users intuitively expect good sites to be 20% approximately faster than their competition, something they call the just noticeable difference. Maybe you care about reach and growth organically, and you care about search engine optimization, in which case it's really important to know that page speed performance is essential, one of the most important factors in deciding Google page ranking. Maybe you're somebody who cares about reaching emerging markets and having their user base, much like ours, not having good access to ubiquitous bandwidth and really good feature phones. In which case, maybe you're building for billions and performance is important. Or maybe I can appeal to the old school of us and cite Larry Wall's 3 great virtues of a programmer: laziness, impatience, and hubris. And I suppose all of them are really important. The first one being minimizing work, the second one being impatient when the computer is being lazy, and the last one, hubris, is the one that's most applicable to this. Maybe you just don't want your site to be slow and have people say bad things about it. Anyway, but besides that point, I'm more specifically here to talk to you about really good tooling and how we can learn it better. And that tooling is Lighthouse. So, what is Lighthouse exactly? Well, it's a bunch of different stuff, but it basically boils down to best practice guidance on how to build fast websites, but broken into something that gives you simple, easily actionable, and clear audit responses. So there's simple pass or fail audits and some simple metrics that aggregate into really easy to understand and easy to socialize scores. And by socialize, I mean socialize with business and product owners without getting into too much jargon. And this is pretty important because it's used by PageSpeed Insights and is increasingly used across performance tooling across the world. So there's a number of key metrics that we care about. First contentful paint, first meaningful paint, time to CPU idle, time to interactive, speed index, and estimated input latency. And these things all roll up into what is our aggregated performance score in Lighthouse. Now, they have very particular weightings, which is 3 parts FCP, 5 parts TTI, and this sounds a little bit like a recipe. So if you break this down into percentages, whatever those individual key scores are, we get to approximately 33% of your score is made up of your time to interactive, the 26% is made up by speed index, 20% by first contentful paint, and the balance of them is made up by the rest. I'm not sure why estimated input latency is there, but hey. So we're going to primarily focus on 3 key scores, which is FCP, TTI, and speed index. Now it's important to remember that these numbers do change over time, and they are looking at revising some of this stuff going forward for the next major release of Lighthouse. So just keep that in mind if you're watching this retroactively. Now, what exactly is FCP? So first contentful paint is the time from when the page starts loading to when any part of the page's content is rendered onto the screen. So the first thing that's literally drawn onto the page. And this is a really important user-facing metric because it's what the user experiences as that white page that they're waiting for until the page loads. So it's the first visual cue that there's something. So obviously an important thing for us to measure from a performance perspective. Speed index is a little bit trickier to define, but it's basically how quickly content is visually displayed during page load. And you can think of it as the progression, visual progression between frames, and making sure that those frames are constantly repainting and moving smoothly and changing. And then the last one, which is most relevant to our discussion today, is something called time to interactive, which is the time from when the page starts loading to when all of its sub-resources have loaded and it's able to respond to user input in a normal fashion. Now this is really important because when we're loading a whole bunch of JavaScript into a page with heavy single page applications or something like that, the page may look like there's stuff that you can click on, but it isn't really interactive until like a second or 2 or 3 or 4 into the page load cycle. So also something really important for us to measure and optimize for. Now, a different visualization of this is looking at after first paint being the first pixel painted onto the screen. First contentful paint would be when the user perceives something is actually happening on the page. First meaningful paint, so that is something happening. First meaningful paint would be in the is it useful stage? Is there stuff that I can consume or read while the page is busy loading? And then the is it usable question, the metric that we really care about there is time to interactive. Now, it's important to note that speed index sort of bridges across all of these things. It's a little bit difficult to visualize. So, with no further ado, let me break down into the demo and show rather than tell. Alright, so for the demo, we're going to use an app that I wrote for a previous talk that is a small little meme generator. I considered using real-world websites to profile against, but people get a little bit fussy when you start showcasing some performance problems that they've got. Anyway, so this app is going to have to do. Now, as I said, it's a simple meme generator app so that I can generate my Lord of the Rings memes where appropriate on the go, and it's important that you know that I believe that there's always an appropriate Lord of the Rings meme. So, if we look at our Chrome DevTools, which is what you can see open on the right here, you might be familiar with this, more familiar with this view. There is this audits pane, and inside this audits pane, this is essentially your Lighthouse report. I'm going to generate this report for this small app, but I'm going to disable everything that is not performance because it'll make the run a little bit faster, and that's all I really care about at the moment. So if I generate that report, it takes a little while. You can see the page reload several times, and I come back with a pretty small site having a pretty awful performance score. Now that's because I've stumbled into a whole bunch of common pitfalls. Now, if I unpack this, so zoom in a little bit, and then unpack this, I can see that my first contentful paint is at 4.7 seconds, my speed index is at 4.7 seconds, and my time to interactive is 4.8 seconds. Now those are the important statistics that we really care about. The rest are all interesting and valuable, but I think are probably highly affected by the first 3 metrics. We can also see the page progression. We can see some audit reports at the bottom here as to things that we can fix, chaining critical requests, and keeping our request counts low and our transfer sizes small. and there's some interesting stuff that I'll dig into there in a moment. And then if we want, we can also look at the raw trace information. Now, if you open this, you'll get a proper full profile report, and you can see the frames as well as the CPU timings for each of our interaction events, and you can see that here is our first contentful paint versus our first paint, versus our first meaningful paint and our largest contentful paint. Time to interactive is probably a little bit further down because we've got a whole bunch of scripts that it's waiting for. Now, I don't pretend to understand the details of how the breakdown and flame chart work, but maybe one day when I'm big I'll be able to read these. Anyway, so back to our audit report. If we look at our keep request counts low and small, it might be very difficult to figure out, well, how do I improve this? This has a breakdown of total transfer size of assets, and obviously we can see that images form a bulk, as in 1.5 megabytes worth of stuff. I get that, you want high quality memes, but surprisingly we're generating a hell of a lot of JavaScript for a very, very small simple application, which is, you know, surprising. Now we need to lean into some other tooling to try and figure out, well, what is this really made of? Now, a little known feature of Chrome DevTools is the fact that you can do a code coverage report on load. So if I go to my console, I select this little radio tab, more tools and coverage, I can smash on reload, and then when it reloads the page, I can see that in my JavaScript, about 56% of it is unused. I can click on it and then go, and it'll show me literally which function calls and what code is not being used, but this is all minified, so it's not very useful to me. Okay, so it becomes very, very difficult to diagnose. CSS is a little bit easier, but that's not a problem for this app. Now, knowing that there is a bundle size problem for unused code, I have a suspicion that it sits behind this plus button for creating a new meme, right? But I'm going to need to dig into that a little bit further. So for that, I'm going to use a tool called Webpack Bundle Analyzer. So if I go to my application, you'll see that here it is built using Webpack into our public folder, and it's a pretty standard Webpack config. And I can use the Webpack CLI to generate additional statistics from this. So if I go to the command line, which is over here somewhere, and I cancel that, and I run a Webpack command, oops, sorry, not that one, Webpack, and pass it the profile and JSON parameters, and write it to a stats.json file. It's going to generate this JSON file, and then I can use the Webpack Bundle Analyzer CLI, which you also saw there, on that stats.json file to unpack it and start this view. Now, this might not seem super helpful at the beginning because it's just one giant index file, but this is what we're serving up. I can go into, rather than the parse JavaScript, the stat version, which is going to show me that here are my dependencies that I'm loading, and here's my source files and concatenated. And then additionally, if I can go show content of concatenated modules, it'll break that up even further, and it'll show me what my bundle is made of. So I can see immediately, like, there is a big chunk of it that is dedicated to material UI, which is only behind that next button. So this is obviously a candidate for optimizing. Now, the first step, let me just close this all down, that we would want to do to optimize this is to split that bundle into multiple chunks and potentially lazy load it. Now, luckily, Webpack understands dynamic import syntax, so we can lazy load very easily with that, but we need our application to also understand it. So this is just a standard, simple little React application. And here in my app.js file is where that new component that sits behind the plus button is located. Now, with very, very minimal changes, I can go and take this new, remove it, and then instead create a new component which is going to be a react.lazy of a function. And that function is going to take a dynamic import of the component new. And everything else in principle works exactly as it's supposed to. So rather than the static import, Webpack is going to pick up the dynamic import and create a separate bundle that we can then download separately. This is not completely going to work, however, because we need to give React some fallback content. So for that, we're going to rely on something called suspense. And suspense is going to be a wrapping component around our new tag. Let's just tidy up here a little bit. And inside here, we're going to create a new suspense component that's going to have fallback. And that fallback is going to be, for example's sake, a div that's going to say loading or something. Cool. And that's going to wrap our new component. And it's almost as simple as that. So when we rebuild the site and we go to our npm run build command, that's going to use our standard webpack config. It's going to spit out a bunch of extra modules, which we're going to show in a moment. Let me just start that up and then reload this whole page. Now, the first thing that we're going to see if I go to the network panel is when I hit that plus button, it goes and it downloads more scripts. So there's lazy loading already in that, and the page is interactive. The proof in the pudding is in the audit report, so let's leave this one here. We're just going to create a new audit report, generate that audit against the now lazy loaded site, and we immediately get a nice bump in performance score, primarily because of our time to interactive. That's because we're downloading less code. So downloading less code that's not executed means that we can become interactive far faster. Cool. There's still more changes that we can make though. For that, we're going to need to explore differential module loading. Now, what do I mean by differential module loading? Well, if I take a look at that Webpack bundle analyzer again, Webpack bundle analyzer, and we take a look at this, we'll see that there is a whole bunch of core JS stuff and things that we're polyfilling in, like promises and typed arrays and symbols and things that we really shouldn't need to inside Chrome, which is a modern browser. That's because we're still falling back to generating stuff that'll work across all browsers that we could possibly run in, like IE11. So instead, what we're going to do is we're going to generate JavaScript for Chrome and modern browsers and JavaScript for IE and load them up separately conditionally. Now that seems a little bit complicated, but it's not as bad as all that. Let's get started. So the first thing we're going to do is we're going to go to our Webpack config, and we need to figure out what is going to be a generic config versus what's going to be our browser-specific config. So what we're going to do is we're going to create a base config class. And that base config class we're just going to set to the whole export for the moment. So let's just move that up. Then we're going to want to create additional specific configs that are going to be for legacy JavaScript, or legacy browsers, and for modern browsers. And we're going to export both of those in an array rather than as a single object. And Webpack understands how to do that. Now, these are going to be a merging of the base settings with very specific Webpack configs for those two environments. And to use that, we're going to use something called Webpack merge. Now, Webpack merge is a little utility that understands how to deep merge Webpack configs. It's very, very specific to task. And for that, we're going to say, well, this is going to be a merge of base with a custom style. And this is going to be a merge of base style config. You know what I mean. Oh, and if I put all my equal signs where they're supposed to be, cool, awesome. Great. So for that, we're going to throw away the Babel rules out of the shared style because there's nothing common across them. The rest of the output JavaScript stuff stays the same largely. The Webpack copying and so on and so forth stays the same. So for legacy, what we're going to end up with is something that approximates the following. Which is going to be, we're going to name it legacy, we're going to put it in a legacy folder in that same public JS directory, and we're going to say, well, keep everything the same as it was. And then for the modern configuration, it's going to look something like this, where we're going to put it in the modern directory, and we're going to target browsers that have more than a 0.25% market share that are not Internet Explorer 11. And we're going to, based off of usage, build the polyfills into what it is that we want. So from that, that's all we need to do there. We export it as an array, and then we can just run build on this. So if we npm run build, which is going to build our Webpack config, it's going to take a little bit of time because Webpack, and then if we just take a look at what our public folder looks like, we can see that our legacy directory has about 380 kilobytes worth of JavaScript, and our modern directory has about 308 kilobytes worth of JavaScript in it, including the splitting previously. So that's a neat reduction in size of about 80 kilobytes of JavaScript, which is significant. Now to get this to work, what we're going to need to do is go to our index.html that is going to load up all of this script. And we've got this script text JavaScript that's going to refer to our legacy JavaScript bundle. And inside that, we're going to add the no module flag. Now the no module flag says that this should only be run inside browsers that do not support type of module. So this means that things like Internet Explorer 11 will run this because they don't actually recognize no module, but then the following, which is going to be a script of type module, they have no idea what to do with. So they'll execute this, whereas browsers that understand this are going to ignore the no module directive or ignore the no module script. So what that means is we can now go in here and we can say js modern index.js, and that should load them up relatively in each of the individual browsers. So if we npm start this, if we haven't broken anything and we reload, the page still works. We're just going to go straight into another audit report. We're going to generate that audit report. And we see a huge jump up from 86% to 97% just by using modern JavaScript, which is great. Now, we can take this a little bit further, and there are really large images. We can perhaps optimize these images to bump it up even further. And to do that, we would go into our Webpack config, and we would just use 2 additional libraries, one of which is ImageMin. So ImageMin is a simple plugin that does image minification. Then we would use the JPEG plugin that's going to use mozJPEG for JPEG minification. And we would use that basically everywhere. So on our base config, we would additionally just add the ImageMin plugin. Oopsie, sorry. There. Now if we rebuild, run build, and then start it up, it will, upon copying across, also optimize the images to be slightly smaller. Now, we're not going to see a huge impact on this when we run it locally, because they're being served locally and they're already cached. But in principle, this should bump us up to 99%. Let's just try that in a new tab. Run another audit report. No. Well, it should bump us up to the 99%, but I suppose there's only so much you can test for. Now, this is great, and it's great to fix issues exploratorily when you realize that you have a problem. But we want to make sure that we keep ourselves from continuing having a problem and prevent ourselves from regressing. So for that, I'm going to run Lighthouse as a set of tests. It's a lot easier than you would expect. I have already installed all of the packages, so I'm just going to create a Lighthouse rc.json file, and inside that lighthouse rc.json we get to specify a bunch of stuff, and that's going to be which URL to run the tests against, which preset to use. I don't care about the PWA stuff for this, and that we want our minimum score of 3 runs to be 99. Okay, now that's all we need there, and we go to our package.json, and we're going to add a new Lighthouse script, and that Lighthouse script is going to just run Lighthouse CI, which is going to in turn start up Chrome and run the full Lighthouse. Okay, so if I have to keep the server running, importantly. I'm going to split the plane horizontally, and then at the bottom I can npm run Lighthouse. It does some audits, just making sure that it's healthy, and then it's going to do 3 runs, which are going to take a little bit of time. Okay, cool, great, so that was done. And you can see that we passed all of our runs, even including the 99% audit. And this is obviously a little bit long to do in terms of the demo, which is why it was sped up. But this would be great to run on a CI build and make sure that you're never regressing in terms of your performance scoring, or to, if you're that kind of person, run on a pre-push hook with Husky. Great. So let's close up now. Okay, so demo done. So in conclusion, what's important to remember is that you need to understand the key events of your page, which parts of the life cycle are crucial to measure and optimize for. In addition to that, understand your tooling, explore, play around, and figure out what it is capable of. And I think the reality is that you're probably going to need a mix of tools. So various different things that work together to try and solve and diagnose these problems. I just advocate that Lighthouse be that first point of call. Then it's important to remember to cut away from the critical path of your page's render, keep those metrics in line, and figure out like what do you not have to do? What is the least amount that you could possibly get away with to render as quickly as possible? And then following on from that, when you're trying to diagnose stuff, when you're trying to figure out how to make your site faster and so on and so forth, make small measurable changes and just make sure that you keep moving that yardstick every moment at a time. And then wherever possible, it's fine to fix something, but there is a lot of evidence that indicates that without continuous monitoring and automation of the monitoring tests, performance degrades and slips, and it's almost as if the site atrophies unless it's constantly being watched. So I strongly recommend that you do then put pieces in place to be able to monitor this over time. Maybe that's Lighthouse CI, or maybe that is other performance tooling like Speed Curve or Page Speed Insights. And then just to leave you with a couple really good resources that I found very helpful. The first is web.dev, and there's two parts that I'd like to talk about. So the first part is web.dev/fast, which might be the coolest URL on the internet. And that is all of the learning resources by the Google team to try and figure out or try and educate people how performance tooling works, how to set up performance tooling, how to create performance cultures, how to monitor it, and some framework-specific advice as well, which is incredibly useful. The second link there, which is web.dev/measure, you can sign in with an account and it will keep track of your page speed insights over time. So it'll run Lighthouse against your URL and give you some high-level guidance as to what's going on and give you some really easy advice over time. Then, second to that, I strongly recommend that if you care about performance, you read Smashing Magazine's Front-End Performance Checklist for 2020. It's a long read, but it probably is the state of performance for the whole web. And it will go through everything from how to secure buy-in for creating a performance culture with business, through to specific tools and comparing a bunch of the tools, as well as what the metrics changes that are incoming mean and what the status quo is in terms of figuring out whether your page is fast or not. Now, please feel free to ask me any questions, reach out. I should be lurking in the chat at some point in time, and I should be available immediately after this to answer any questions if anybody has it live. If you don't feel comfortable in this forum, please feel free to reach out to me on Twitter, and I write some articles on this and other related JavaScript issues at my website. Thanks for bearing with me, and please stay safe.
Hey, so I'm live. Hello, that was a distraction. So yes, thank you very much. There are some questions that were asked during the presentation. Again, sorry I didn't present it live. I was a little bit worried about internet hiccups. Cool. So the first comment I suppose we had was about the t-shirt. Thank you very much. It's an awesome t-shirt that I got in Mountain View. It's one of my favorites and I wear it whenever I can when I speak. There was a very important question about Lighthouse audit reports and whether the Lighthouse audit reports can be used with server-side rendered applications. Yes, absolutely. It's basically exactly the same. I can quickly show. Let me show. Okay, I'm going to share my screen quickly. Can I do that? I can do that. So if everyone can see my screen, am I showing the right screen? I think so. I don't think so. Anyway, perhaps I should have practiced that first. Can see it. Cool. Awesome. So if we go to incognito, I'm just going to, I was tempted to use DevConf as a site, but Robert did too good a job on the DevConf site, so it didn't present a very nice audit. So if I generate the report on a DevConf site, and that's all statically generated stuff, you can see that when it's done, it gets a really, really good performance score, with the exception of some images, and those are obviously like images that are big profile pictures and so on and so forth. And there are some render blocking resources in terms of CSS. And this is all statically generated. Can you see that? Is that a bit better? So this is all statically generated. And then you can, in the exact same way, go and do a code coverage report on this site. And here, unlike the JavaScript, you'll see that the code coverage comes back with a whole bunch of CSS that could be trimmed. So there's about 20 kilobytes worth of CSS that's not being used on page load. So it is still useful doing the Lighthouse audits on server-side rendered stuff. And obviously for server-side rendered stuff, there are other things that make a bigger difference. So the first contentful paint is something you want to optimize for more than time to interactive. And you care a lot about your time to first byte. I think we're seeing the wrong screen. Oh no, did I share the big screen? I'm really sorry. I'll do that again. Desktop 1. Okay, now I'm sharing the right screen. Sorry. So here is the very good score. And you can see that the single biggest render blocking resource is the CSS. Let's just do that again. Should maybe have practiced this beforehand. I'm really sorry. This is why you should never go off script. Okay. And there you can see the 20 kilobytes of unused CSS in the main.css file. Cool. There was also additional question about disabling the cache. The audit report, the Lighthouse audit report, is a clean run. So you'll notice that when I run it, I'm running it incognito. I recommend doing all of your performance stuff in incognito anyway. If you're exploring like the code coverage stuff, make sure to disable cache on the network panel. But when you run a new Lighthouse audit itself, this will be a complete clean run. It will reset everything, reset the cache, and basically do a hard reset of this browser page and run it in isolation. The only thing that you need to keep in mind is that if you do have plugins that you enable in incognito mode, browser plugins, they may interfere with your Lighthouse run. But if Lighthouse picks up that there's a browser plugin that is interfering with your page, it will warn you in a big bar across the top. Okay. Then about the steam train passing my house, I'm really sorry. I forgot to switch off the audio canceling on my headphones for a period of time, and I think it caused some interference with the microphone and recording. Then does the programming language affect the performance report? So no, not directly, because obviously at the end of the day, the browser is just running JavaScript, HTML, and CSS. But having said that, if you pick a programming language or framework that's known to be slow in terms of rendering or slower, that will impact your first contentful paint. So there might be some of that you see, but unless you get to like the hyper optimization where you're trying to shave off milliseconds, it's probably not going to make a big difference. Let me stop sharing. An important thing to remember is that your choice of framework does impact that. So I showed React because React is a relatively middle of the road in terms of performance framework. There are obviously heavier duty frameworks that are going to have a far bigger performance impact in terms of the page speed. And there are others that are going to be far lighter. And it's just keep an eye on which ones to use. When including a module, I'm going to share again. Sorry, this is another thing that I forgot to mention. You can look at something called bundle phobia. You can see that I use bundle phobia quite a lot. Okay, so bundle phobia is when you want to install a package onto your application, you can put it in bundle phobia and it'll show you what your minified and gzipped or minified sizes are. So minified and gzip is the thing, basically what your transfer over the wire is going to be, but the actual minified size is what's going to be unpacked and parsed and compiled into your browser. So that's important to remember. And then the next question is, how can I optimize my Webpack config if I use React scripts to build and not Webpack in its own? Create React app, absolutely. So that's a very, very good question. This talk was actually, the project was originally a Create React app application. And for that scenario, unfortunately, Create React app hides a lot of the power from you. So you are going to have to eject from Create React app if you want to do this level of customization. And that sucks, and I'm sorry. But that's only really if you want to customize your Webpack config. I think the official guidance from the Create React app folks is that if you want to do something more concrete, you should create your own fork of Create React app and then just modify it slightly. But that doesn't seem very valuable because then you're maintaining a fork. But it's just one of those things. Like the convenience traded off against the ability to tweak the underlying bits and pieces. There are some questions inside Slack, which I'm also going to just see. Yes, I showed the wrong screen. I'm really sorry, everybody. The coverage report, yes, is something that is very useful and very few people know about. And the thing that's difficult is looking at the coverage report and then trying to figure out, well, what does this actually mean? So I recommend Bundle Analyzer. I use Bundle Analyzer on my production code every day. Well, not every day, but when doing performance tuning of the site. Would there be big differences if I was optimizing Next.js or Gatsby? No, there are not huge differences in terms of the workflow, because it's just that the things that you target would be a little bit different. So when I showed the example about DevConf site or anything that's more static content, Next and Gatsby would fall into that world, right? Where you want to check your CSS and your images and make sure that your first contentful paint happens as soon as possible. But the workflow would be very, very similar. And the talk was recorded. I mean, it was pre-recorded, and DevConf will be releasing it at some point in time, and I'll make the code available as soon as this talk is done. So that's me. Any other questions? You can ask on any one of the channels, either on Slack or on the stream, I suppose, and I can answer them. Recommended learning resources for getting started with Webpack optimizations. Those are usually very task focused, like what you want to do. Webpack is a really confusing beast, so their documentation is not incredibly useful. That web.dev site that I linked, so I linked both in the Slack channel and is in the slides, that has some specific stuff around framework advice and using Webpack in some specific examples, which is useful. Other than that, there is another thing that I can recommend, which is something called Survive.js Webpack. I use this quite a lot. So it is a course with an ebook on it. But the ebook is one of those that you can read for free online. And there's a whole bunch of stuff in here that I can strongly recommend, like how to work with Webpack Dev Server properly. One that I use frequently is, where is it? Composing configurations. This is how I do my Webpack configurations, for example's sake, rather than one monolithic file. So there's a lot of stuff here. I'll post this link in all of the places as well. And I'll post it straight to that link. So that's Survive.js for Webpack configs. And yes, again, I will post the code. I will post the code in Slack as well. No further questions. Angular versus React. You're not going to ask me this question on live. I'm not going to do that. This is recorded. You know that. No matter what I say, somebody's going to get cross with me. So I'm going to answer with the only reasonable answer, and that is vanilla JavaScript. Cool. So thank you very much, everybody. That was lots of fun, and I will lurk around in the Slack channel a little bit longer. So if you do have any other questions, I'll answer them directly. So good luck. Enjoy the rest of DevConf, and really importantly, stay safe out there. Bye.